Hello friends, I'm Commander Atul Rohatgi from ISHRAE Institute of Excellence. I'm going to talk to you today while continuing the series of talks which is called IIE Delhi HVAC Talks. Today our topic of discussion will be psychrometric processes that I started and the first process of change in conditions of air that can be called because of pure sensible heating. So, what is pure sensible heating? Pure sensible heating involves sensible heating of air. I mean, it could be done with the help of an electrical heater, or it could be done with the help of a hot water coil or hot oil coil. Oil could be heated with the help of any equipment, electrically or anything else, or water with the help of a boiler or with the help of solar power, whatever. And in case if the coil of this hot water or hot oil is there inside the air which is being studied, so the effect on which we are studying. So in case if the coil is there and if hot oil is circulating or hot water is circulating or we are providing heat with the help of electrical heater, the temperature will increase. This is dry bulb temperature. The humidity in this process is kept unchanged. We are not adding water vapor, we are not removing water vapor. So when water vapor is not added, water vapor is not removed, the absolute humidity of air remains constant. So now what will be the nature of this process like? As dry bulb temperature increases and as dry bulb temperature is measured on the x-axis, when we move from left to right on the psychrometric chart, the temperature increases. So when the temperature increases from one point to another because of the sensible heat that we have given, the process line will move from left to right horizontally. Will there be any vertical movement also? The absolute humidity is read on the right, on the y-axis, and because W is not being changed, so there will be no change in vertical direction in the position of W. So the process line will remain completely horizontal. Now let's see that on the seven psychrometric parameters that we have talked about earlier, how this kind of sensible heating will impact them. See, when we are moving left to right, this red line is depicting the change, the process line. We are moving from dBT1 to dBT2, and as we know that on the x-axis, when we move from left to right, the dry bulb temperature increases. So dry bulb temperature will have an increase. What will happen to the wet bulb temperature? Wet bulb temperature is read uh, along this kind of line. See these lines which are there, they are constant wet bulb temperature lines. And to read the wet bulb temperature at any given point, we have to draw a line which is parallel to these lines, and on the saturation line wherever these lines intersect, we can read the wet bulb temperature. So the starting wet bulb temperature was here, the final wet bulb temperature is here, wet bulb temperature 2. And as when we move from left to right on this curved line, saturation line, the temperature WBT will increases. So WBT increases in this case, in the case of heating, pure sensible heating. What happens to dew point? Now this is the third point. And how do we read dew point? First of all, dew point is read when we move horizontally from any given point to the left, and at the point of intersection we can read the dew point. So we can see that as this line is completely horizontal, this the horizontal movement, the point of intersection will remain same, and therefore dew point temperature 1 and dew point temperature 2 will be same. It will remain constant, there will be no change. So this is what we are writing here in down below in this table, that there will be no change in dew point. Now let's study what will be the impact on W. As we have discussed earlier, that the heat is not being changed. So when what is the meaning of latent heat not being changed? How do we change the latent heat? In case if we supply water vapor, then latent heat will increase. In case if we remove water vapor, then latent heat will decrease. But in case if we are not doing anything, as in this case of electrical heating, the latent heat, the absolute humidity, the actual amount of water vapor present in unit mass of dry air will remain constant. There will be no change. This is read on the y-axis, and when we project these any point on the y-axis horizontally, then we can read the W value, and in this case W1 and W2 will remain constant. So we have written here W constant. Now the value of H. What is H? H is enthalpy. Enthalpy is the total energy. Total energy, which is sum of sensible heat as well as latent heat per unit mass. And now when we are giving sensible heat, we are moving from point 1 to point 2. The latent heat is not changing. Latent heat is constant. But what happens to sensible heat? Sensible heat increases. So, therefore, the sum of sensible heat and latent heat will increase, and latent heat the total energy is read on a line that is parallel to these constant wet bulb temperature line or constant enthalpy lines, uh, and the scale is here. This is the scale is here. So when we move from here to this point, the enthalpy value increases from H1 to S2. So enthalpy increases, and we have marked down below the enthalpy has increased. What happens to RH? That is relative humidity. The When we move from point 1 to point 2, the total water vapor carrying capacity of air increases. Water vapor, what is the water vapor carrying capacity of air? This is the water vapor carrying capacity. This is the maximum amount of water vapor that air can carry. What is the maximum amount of water vapor? Much, much more than this. And this maximum amount of water vapor that can be present in air, that is in the denominator. RH is a ratio of actual amount of water vapor present in air at any given temperature divided by the maximum amount of water vapor that can be present at the same temperature. So the numerator remains constant, the denominator increases from this value to a value somewhere here. Okay, the denominator increases, and therefore this ratio will decrease, and that's what we have written, that RH decreases. And now the final question: what happens to specific volume? How is a specific volume read? These are constant specific volume lines. These inclined lines which have got a much larger, higher slope as compared to the constant WBT lines. These are constant specific volume lines. So what we have done is that we have drawn two lines which are parallel to specific constant specific volume lines. So the specific volume changes from this value to this value. The scale is written here on this, and as you understand that when we heat up air, keeping the pressure constant, when we heat up air keeping the pressure constant, the volume occupied by unit mass of dry air will increase. So the specific volume increases. So I hope you have understood the effects of pure sensible heating on all the 7 parameters of psychrometry. Thank you very much. We will come back with more information, more instructions, more informative videos to you. Thank you for the time being. And I would like to say that join the ISHRAE Institute of Excellence in case if you want to boost your knowledge and skills in HVAC. In case if you are a fresher, then you can join us to start your career journey in HVAC. And in case if you are already working, then you can come to us to sharpen your skills, to sharpen your knowledge so that your image and prestige and your career prospects in HVAC industry increase. You can contact us on these numbers. I'm Atul Rohatgi and Mr. Syam Singh. You can contact on any one of us. We also have YouTube through which you are seeing this video. IIE Delhi HVAC Talks. You can visit that to know what all we have talked till now. And if you want to have some more specific discussions with us, do call us. Thank you very much.